learning time. On the screen is an NTSB report about a 787 Dreamliner that took off in 2024 May from Singapore. Doesn't matter who it is. It's not United Airlines' fault. Nothing to do with them. So this report is about the aircraft having an engine failure. There was some vibration, and the aircraft saw loss of one engine. So this report has lots of good information. I'm just going to start reading through the important stuff that I want you to know about. Definition of the recorder. There are two, front and rear. The GE EAFR, which is an enhanced airborne flight recorder, multifunction recorder. It's got the flight data recorder and the cockpit voice recorder data. Also does comms from your microphones, navigation, surveillance stuff from the line replaceable aircraft surveillance units. They've got two of these, as I just mentioned, forward and aft. The forward is powered by the left primarily, and if that fails, it's got its own battery, and the rear is powered by the right. The forward recorder, as I just mentioned, also has the independent battery power supply to provide up to 10 minutes of time in the event of a loss of the 28-volt DC bus. They're preparing for the loss of 28-volt DC bus power. Should be impossible, but they're preparing just in case. That means it's possible. So this recorder has an integral flight data acquisition. So this is gathering that data from many sources, a bit different to the way flight data recorders used to work. This is recording almost everything on the network. Each frame can vary in length and structure. And importantly, if a sensor or remote data concentrator can no longer send information, if no new data has been received since the last time a parameters value, for example, a fuel switch. So if nothing's been received and it's lost it, right, the acquisition function will continue to transmit the last value received. These data are referred to as stale. So it's stale. Once it becomes unupdated, it can't get new one. It just keeps broadcasting the state that it was in. So that means in case that happens, they need multiple sources of acquisition of the same kind of data. That might mean multiple remote data concentrators or different ways of looking at the result of that action. Fuel control switch, fuel control relay. For some parameters, the flight data acquisition function has multiple prioritized data sources, meaning switch first, relay second, or relay first, switch second, I don't know. Different priorities from which it receives parameter values, meaning if you lose the power to the remote data concentrator and the bus power control unit can tell you what the downstream relay is doing, well, it'll use that. It has a higher priority. It's recognized something changed that overrides the signal from the switch for the flight data recorder. So it records that. For those parameters, a source index parameter, indexing, meaning prioritizing and indexing, indicating the source is generated and recorded by the flight data recorder, or EAFR. For parameters where the source index stale data is indicated by the index being set to no source available. So it's not just like, it doesn't just look off, it says no source available. Parameters that only have a single source do not have a recorded indication that data could be stale. Now that's interesting. Now the switches do have two sources, the switches themselves. They've got left remote data concentrator and right remote data concentrator. And then if they had switched to off, both of those data concentrators would have seen the off signal. The remote data concentrator, we're looking at just the right, okay, RDCs. They've got an input from the switch here and another input from the switch here. Left RDC, right RDC. That goes to the common data network for things like showing when the fuel control switches have been set to shut down, not fail, shut down. If the switches are in cut off, it would be in engine shutdown, commanded shutdown, not engine fail. Now in this one, both the data recorders were in good condition, and the data was extracted normally. It contained 49 hours. Timing of the flight data recorder was measured in subframe reference numbers equal to, with each SRN equal to 1 elapsed second. 1 second increments. That's all we've got, which means anything that says in the flight data recorder something happened, if it happened a second apart, it could be anywhere between 0.1 to 1.9 seconds, thereabouts. Okay, it's only 1 second accuracy. It could be right before the next second starts counting, or it could be at the end of it. So it's anywhere between 0 to 2, effectively. Anywhere between those. Anything that isn't lined up perfectly could be more than 2. So what I'm saying here is the resolution of these things is just polling at 1 second intervals, effectively. In this one, they set it to, the aircraft was at stable flight at 31,000 feet, 300 odd knots, computed airspeed, engine 1, left engine, N1 and N2, and the fuel flow all abruptly decreased, and the fire warning came on. And then it says the engine 1 fuel cutoff switch was moved from the run position to the cutoff position. And that's sensible at 14:09:24. It says that it was moved from the run position to the cutoff position. Fire switch was also pulled. Let's have a look at that. That's saying at 14:08:48, 2 hours, 8 minutes, 48 seconds was the problem. 2 hours, 8 minutes, 55 seconds was the fire warning. The cutoff, 9 minutes, 24. A good 30 seconds it took them to react and shut down the engine. To actually physically do it. This is a real one. That's how long it takes a pilot to react. Let's look at the data. This is quite zoomed out. If I keep going, I get more detail zoomed into the event. I like this one. This is zoomed in all the way. These are 30 seconds to 00. That's 30 seconds, which means 5, 10, 15, 20, 25, 30 seconds, which means that these are 5-second intervals, which means there should be 5 samples in between each one of these lines. So we're looking at this stuff here. This is interesting. The engine N1 and the engine N1 in orange and the N2. You can see they've got this slightly more bold grey line here at 60 and 80%. 60% is your minimum ground idle, roughly. 80% would be a calculated flight idle, roughly. So they're putting this on here to show you where minimum ground idle and flight idle would be. Engine failure is detected when the aircraft's engines go below minimum idle. Here. This point. Flight idle would take less time because we're talking about 80%. So it took the N2 approximately, I'm going to call that 4.5 seconds from there to there, plus another 6 seconds to get from there to there. So therefore, to me, it looks about 10 seconds between there to 60%. 10 seconds it took the N2 to go from there to there. Now, scroll down, fuel cutoff. It says cutoff, not cutoff. It does not say cutoff and run, does it not? Why is it saying cutoff, not cutoff, instead of cutoff and run? I don't know. However, this is how the fuel control relay works, not the switch, the relay. So if we're looking at that cutoff event, cutoff and not cutoff, the only thing to me that gives us a cutoff and not cutoff is the downstream relay, which sends a ground signal to the bus power control unit to tell the bus power control unit that the fuel switch is in cutoff. If it's in run, it doesn't send anything to anywhere. It doesn't go anywhere. Let's have a look at that in great detail in the real circuit diagram. This here is fuel control relay number 2. In the run position, this would be up the top. In the cutoff position, this would be down. This was the thing I showed you before in this diagram. That there is this. It goes across to the bus power control units, left and right, to send a signal to those to tell it a ground is provided through both bus power control units through a non-time delayed relay. That's the relay we just spoke about. To tell it to start things like the power transfers, load management functions. It's called a run to cutoff transition. Transition. You will see that the bus power control unit then goes through the common data network to the common computing resource cabinets. What does that give you? It gives you flight data recorder data. Does it not? The signal that you have been told was someone transitioning the switch from run to cutoff was not. This relay is a dual coil electromagnetic latching relay. A dual coil electromagnetic latching relay must be wired in polarity correct. The coils work against each other, not at the same time. The coils are oriented and need the correct polarity to push and pull the pin inside the relay in the correct direction. Reversal of that polarity can, if the voltage is correct, will, if the voltage is correct, reverse actuate the relay in the unintended direction. Therefore, if I am able to send electricity from the captain's instrument bus the wrong way, if I can send it from the ground through a broken diode, if I can send it through the ground, through the switch, back through the run, beg your pardon, we're looking at this one here, back through the run signal. Okay, the switch is in run position there, it's up the top. If we can send the power backwards through the run signal to this relay, backwards through the run, it will push it down instead of pulling it up. That will send all of these things to cutoff, including the actual fuel control cutoff to the spar valve. The same can be said for the high pressure shutoff valve control circuit. Let's have a look at that. As for the other one, going up, run, follow the run wire, through, up, through, into the high pressure shutoff relay. This is relay 1, there are 2 per engine. Reverse that through the run coil, set the run coil to push instead of pull, backwards through the reverse current DC buses through the broken diode, and you have a commanded shutdown. A commanded shutdown is only half of what is required. We then need DC power. There are many other buses and sources of electrical power on this aircraft. All that would have been required to hit the high pressure shutoff valve was to send this relay, this is the relay, from the high pressure shutoff valve into the fuel metering unit to tell it to shut down the shutoff solenoid. This is not a dual coil latching relay. This is a simple electromagnetic, like inductor. It does not matter which way current flows through this. This can be reversed and it will tell as long as there is current flowing. Provided there was some kind of power, be it reverse, whichever direction, it would make its way through the contact, not as a ground signal, but as a power source, and it would tell this thing, current, actuate. It shouldn't happen unless this goes to cutoff. It did because this pushed it down because of the reverse polarity on the run coil. The run coil must be wired correct polarity or else it will reverse actuate. That push down sent the good reverse power through this, which told the FMU, I'm being told to shut down, which opened up the bleed of the shutoff solenoid, lets low pressure fuel into the shuttle valve, and shuts it immediately. At the same time, the spar valves were doing the same thing and taking their time shutting down with the electricity powered by the fuel shutoff module. This here is the source of emergency power for up to 3 or 4 valve closures in the event of a complete power failure, which makes this thing turn around very slowly and shut the spar valve. What you have been told is either a result of incompetence at the investigation, trickery from those who know how it works trying to convince the investigators to get themselves off the hook, or just pure, downright, complete international conspiracy. I am not a conspiracy theorist. I am a conspiracy factualist. I've looked at how the aircraft works. It was impossible to happen as reported in the preliminary report. 100% impossible. You've been lied to. And I'm not here to argue with you. I'm here to tell you what happened. To tell you with 100% certainty that this was a result of an electrical disturbance, and you have been fooled, and you will only be fooled for so long. So to recap, this is not the switch. This is the relay located in the electronics bay, just below the pilots. Alright, in the P300 power panel, and then the electrical load control, there is a relay plugged into the circuit board. Unfortunately, there are things that I'm not allowed to share with you. You just have to trust me that I'm not just some enthusiast. I know what happened.